But now time to back to work. You can give me suggestions in the chat. What was there recently? As a warm-up, I can as well choose something from one of those 2 rounds and then think about next problems. Hi Amir, Samrat, hi. So what do we want to solve? Lakshay, hi. San. Home current medians. What about this one? Nice wallpaper. Oh, thank you. You mean the background or the wallpaper here? What will this be about? Just reading this to see if it's worth solving. There is an array, and then there is sequence of prefix medians. And now we need to reconstruct the initial array. Right. Solve C first. I think I will start with this one. Now that I already read it. Why did I give Code Jam round 3? Why did not give? You don't give a contest. I participated in my laptop because I wasn't home. Via my laptop. I think that's already a well-known fact that I don't like a phrase to give a contest. It's hot today. Maybe I need to move my streams to 1 hour later. It will be colder. Grab the link now. Oh, and my Discord server, I need to make a ping there. And done. Oh, I temporarily at least fixed my drawing tablet. I think. Does it work? Yeah, it works. Now I have this keyboard popping up. I didn't manage to turn it off. I had like half an hour for that. Annoying stuff. Alright. We are given this and we need to find an array such that this is median of that. If you see that 6 is median of some prefix, then well, that prefix is just 6. Then you see 2, so you need to add a 2 and another 2. Now you have 6 to 2. And then you want to create 1 and you're not able to do that. Right? Well, let's work with this sequence, I guess. This is medians.cpp. Six to 1 3. For this input, we start with 6. Then I know I want 6, 2 and 2. Actually, 2 and something smaller than 2 will be fine. Like 1. This can be 1. Oh, so 6 to 1 is possible to achieve. Then that has the median of 2. This I know is smaller than 2. Then I want median 1. Well, this question mark, I knew it's smaller than 1. So will there always be, in some sequence already decided, it seems that some numbers are decided completely, some they are in interval, like here 1 minus. This means that it's 1 or smaller than 1. Maybe here it must be 7, here it must be greater than 3. Do we ever need an interval? Oh. But then, if we know that this must be the median, we can change one of those numbers. We can say that this is actually now this thing, maybe let's say 4. And those two numbers, sometimes they are very flexible. Maybe we should go backwards. Maybe that's easier. Should I always fill the leftmost number with the new one? Can I do anything backwards? I know the median of everything. That's not a trivial problem. I don't know how to solve it. N cubic dp problems. I don't think there's something special about n cubic dp problems. I have a lot of content on dynamic programming. N cubic isn't something special compared to other complexities. I don't think there is any possible learning specific about some time complexity. Either you know dp or you don't. Median can only be between L and R at each step. Well, we know median, so we don't really care in what interval it can be. We need to care about how to assign numbers. Infinity and minus infinity. But that might hurt. Like here, this is 1 or smaller. And you say that this should be minus infinity. Well, not necessarily. So this is question mark, 1 or smaller, and maybe later it will turn out that we want a median of 1. What I want to say that this might help us get exactly some value. We cannot make it too small. But if later I want a median of, let's say, 1, then I will just make those numbers to be 1. When should I change this? Does it help to make this number to be 1 rather than minus infinity? When does it matter? Let's say that this prefix, I want some particular median. And minus infinity is bad here because I actually want median, let's say, 1 or 0. But with this thing, if I put minus infinity here, I can put 1 there. If I put 1 there, then what? Do I want 1s also there? As well, I can put minus infinity. Yeah, maybe Timothy is right, but I'm not sure about that. It is hard to debug n cubic problems. I agree. But there isn't any trick to that. You can see in plenty of my screencasts how I debug. If we have 1, 3, 7, 9, 11. Oh, but I don't see how to use the fact that the new number can be in some interval, and otherwise there is no solution. Assuming that let's assume that there is a solution. in particular, I need to solve cases where the answer is yes, and then figure out interval for the next number in the input doesn't help. Of course, understanding the reason why it's interval 3,9, that maybe helps, but not directly. It's not better than thinking like what I do right now. You can move the median. Olimpo, this is what I'm thinking now. That if I put here minus infinity, and maybe it turns out, oh, this is bad because now median becomes -5 instead of 1. So what then? For this prefix, the order doesn't matter. So maybe for this one it does matter. No, for any prefix the order doesn't matter. If I could here put my 1 instead of minus infinity, then it means that this prefix, it doesn't care whether this is 1 or minus infinity. And what about this guy? Let's say that this was satisfied and this is now bad. We cannot get this to have a proper median. But if I put here 1, I could. But then I can swap one of those two values with minus infinity to make it not minus infinity. Somewhere here there is that median of 1 that I need. Let's say it's 1. It must be one of those numbers. Well, it can be here. No, it cannot. Installing Ubuntu after watching me? Oh, I'm not sure if that's a good approach. Best alternative to LeetCode if you don't want to burn $100 annually? Isn't LeetCode without premium enough? Yeah, 213 is impossible. I still try to get a proof for this, not really figure out when something is possible and when it's not. We need to construct a sequence, so I think we will do it greedily. It's not that hard of a problem if it's division 2D. It cannot be very complicated, you know, with multiple data structures. So what we can do is use greedy, where numbers so far will be kept in a set or maybe 2 sets for smaller and bigger values. The code shouldn't get more complicated than that for this slot of difficulty. The question is basic. If I build grid, can I build the sequence greedily? And for this sequence of medians, can I already say that this is the sequence I'm building? My streams random? No. They are... I had a break last week, but other than that, they are random. They are scheduled. Assume that minus infinity is x smaller than 2. Yeah, but I can do this. You can say that it's 1 minus, but then eventually the situation will be that I need to get some median, so I need to replace some of the values in this prefix, and I will not know which values to replace. If we figure out why 2 and 3 is impossible, we will arrive to the solution. I doubt it. We can do it your way. Why 2 and 3 is impossible? Because we need to get first 2, then 1 and something smaller than 1. Actually, 1 is also fine. And then we want to get 3, so we want 2 numbers bigger than 3. Okay, done. And I mean, still this median will be 2. Okay, yeah, this is impossible. So what? I knew that it will be easy to figure out why the answer is no in this case. And what do we do now? The latest round 3 of CodeJam? What do you mean rate to IOI? Like the quality of problems? They were fine. I don't participate in IOI or ICPC now, so hard to compare. Am I alright? Well, I was sad not to advance, but I'm fine. Difficulty? You can compare people who participate in both. I don't know. Take any participant who participated in IOI and Google CodeJam, or any pair of that, and you will compare the difficulty. And then let us know what's the answer. So now back to greedy thing. The only thing that is doable seems to be that this will be minus infinity. Why is it fine? Smallest numbers and biggest will never matter. I mean, it's obvious to say why minus infinity doesn't make any difference compared to minus infinity plus 1. Here it's actually L over 2, where L is the current length of the sequence. Because they will not affect the median. It just matters that they are there. Look at the 2 and 3 example. Yes, I already showed how 3 is impossible, so what? Median can shift just left or right. Well, maybe I should look at the sequence of already existing numbers always sorted, like minus infinity, 2 and 6. And if this is the median and I add 2 numbers, if I add them, say here, then this will be the new median. So indeed, we can only move to a neighboring number. So either to something created here right now, like a 4, slightly smaller than 2 as well, or to one of those 2 neighbors. And because we can always add 2 numbers, one of them just can be this guy. If I now want a median of 6, would it hurt to put a 6 here? And maybe infinity there? Yes, it hurts because then I cannot get 7. And if instead I added 2 infinities, I could add here 7, or say that this is a 7. We can prove with this that median never reaches minus infinity or plus infinity. Oh, yeah, I understand that median will not become minus infinity. That's not the proof that it's good to put minus infinity here. Maybe instead of infinity, it's better to use a 1, because maybe we want to use this median 1. Watch if there is some integer between I median and I minus first. But what you're talking about is... Oh. The answer is yes or no. I wanted to reconstruct the array. I see. I see. Well... Okay, with reconstructing I can guess more, because I don't need to understand how exactly to create the sequence. Yes, no is easier? Well, it can only be easier, right? If you have a constructive solution where if you construct the answer, then you in particular know if it's possible or not. Okay, do I use what, 2 sets or an ordered set? I can also do offline and segment tree. What will I do? Always I need to say that a new median, if I have in the input 1 and then 3 just after that, there shouldn't be any 2 earlier. Is that it? Constructive version of this problem would be more interesting because you would need to understand more what's going on, not just guess. Even right now, I'm not understanding this fully. I don't need to remember this. Actually, it will be convenient to keep that. Do this. I is not 0. Then compare to the previous element, ai minus 1. And check if there is something between them. Does it matter that this is that there are repetitions? I think it can matter. Well, those repetitions in the input, that they don't denote repetitions in the sequence. If multiple times I got median 6, maybe it was the same value 6, like this sequence, 6 to 10, 1, 11. Always the median is 6 if we take a look at any prefix of odd length. Not hard to reconstruct if you have the correct solution? Maybe. But it's not easier. When I see... Yeah, I will assume that repetitions in the input don't matter that much. And I will not even have a multiset, just a set. If this is the case, I just need to insert AI. I think second returns iterator to this inserted thing. No, not first. Second is Boolean value wherever it was really inserted. And then what? Previous or next? Let's, for convenience, put here -1 and infinity, or -infinity and infinity would be fine. If not true, or if previous is different than AFI -1, and next is different than that. So if you're not neighbors, well, and you're not that, then this is bad. We shouldn't break here because we keep reading the input. I don't know, maybe that's it. Maybe. What's wrong? Values can be negative, alright? So this should be real infinity, not just -1. Yes, yes, yes. I already copied, right? I don't know, works for samples. Please explain. Explain what? I don't really feel satisfied after solving this problem. It was guessing more than understanding. I exceeded your expectations. You're welcome. You didn't expect somebody not to understand stuff. Explain your solution. I'm telling you everything I'm thinking. Come on. My solution is exactly what I typed, so it's not hard to understand from code. I don't know why it works. I mean, it's obvious that if this is not satisfied, then the answer is false. Otherwise, it's not obvious. For example, what do we do with ties? What kind of construction are we talking about? We have some sorted sequence, I guess, so far, like maybe I know that so far I used 2, 6, and 10, or it's more like 2, 6, and unknown, always infinity. And now I want median of 4, then I add 4 and minus infinity. I want now median 4, then I do nothing for consistency. Let's say now I want median of 6. I guess that. Median of 7. Then add 7 and plus infinity. Alright, it seems easy. Then this is a proof. This construction is a proof that if the new median, it's not crazy different, so there isn't a gap between like now 7 and now I will say 5. This is bad because there is 6 in between. Even adding two minus infinities, I cannot jump over 6. Yeah. Okay, then it's fine. Now that I think like this, it seems easy to say that if this condition didn't fail, we got to the end, and indeed the answer is no. And this is the construction. Read the editorial proof. I think it will do something similar. Insert, how it works. Insert returns a pair. It returns a pair iterator where it's inserted, and true or false whether it was indeed inserted. So second will give you Boolean value, and it will be true if that is a new element and you inserted it, false if actually you failed to insert because it was already there. Now for everything like that, if you don't know what happened, then you can always, like, well, because it's first, then apparently this is a pair, then just use Google to figure this out. C++ set insert. And it will tell you the returned value. It returns a pair, iterator, something. This is, I like to give you, the viewers, rod rather than a fish. So always, you don't understand something like that, You need to Google C++ reference set insert. Java, stop spamming, come on. My code is a legal proof of why infinities work? No, it isn't. I wouldn't say that my code is any kind of proof here. It's far away from one. Next and previous give you next iterator, like iterator plus one. So this is like saying it plus one. They are logarithmic. I think they are logarithmic. Pessimistically and I think also expectedly. Do we do E? I don't know, E seems hard. Maybe not that hard, but harder than I would want it to be. This problem I did was 2000. So let's not go much higher than that. What's the difficulty here? Did I turn it off in my settings? Oh, I don't have a plugin here. Let's see. Now, what you see now is Windows, not Ubuntu. I think I have a plugin and it will show me difficulty of unsolved problem. Yeah, 2300, I don't know. Let's do some voting. What do I want? Straw poll. I think we will do the first category. Great poll. Here you go. You can vote on whether I should now, today, solve problems up to the difficulty of this problem we did a moment ago, which was 2000, or we should go more difficult. Also, I didn't upsolve Google CodeGem today because I preferred easier problems. And in the meantime, I'm going to read the editorial. I would say that the length of this editorial shows that I wasn't wrong to not understand it for such a long time. If you cannot write down the proof in one paragraph, doesn't that mean it's not trivial? Also, people in the chat, some people in the chat provided some very incorrect proof, like this shows that this is clearly it, or something like that. It wasn't trivial. I understand this casework. They talk about those adding to infinities or minus and plus infinity or that. Sure. Can you do E followed by 15 to 2000 if that wins? It seems to be unnecessary or maybe not consistent. Where is my poll? Did I remove it? What are the results? Oh, pretty split. Let's stay at difficulty of up to 2000. I will find another problem, but I will do it here so I would see the difficulties. Difficulty of the problem, it's a plugin. Also, it's a plugin. If you Google Codeforces, show difficulty tags, you will find it. What about here? CD. $1,800. The statement is very long. Is this one worth it? I think I would prefer to skip it unless you tell me that it's very interesting. Solve E. I mean, E will for sure be more difficult. No and skip. Yeah, okay. Let's do that then. In problem set, do I see difficulties? I see that. Oh, yeah, that's great. We're looking at almost 2000. Armchairs. And over 2. That's for sure something with median. Do we do this one? It is binary lifting. Oh, don't spoil like that. It's... I don't know. Maybe you should. I'm not sure. But like, you're then spoiling it fully for everybody. Java, I don't believe you. I also remember that once you told us that you know something and you didn't then describe the solution or the proof. Can you do it as optimally as possible? I can argue that you should say, can you do it optimally? And that's enough. No? Optimally already means optimally as possible. And usually then we just think about optimal time complexity. Alright, let's do this thing. I can explain the problem. Where? I don't know the problem. I just heard Java, I don't believe you out of nowhere. Yeah, Java is tricky. Sometimes I'm not sure if something will be passed by value or by reference. So it really makes sense not to trust Java. In C++, it's fairly obvious, like whether something happens by value or reference. You cannot even trust Java to sort an array in n-log n. It can do it in quadratic time. Alright, armchairs. And chairs, some are occupied by people. Number of occupied armchairs is not greater than n over 2. I already told you recently, like a week ago, if there is a condition of n over 2, or especially greater than that, often the solution involves randomization. Maybe not here, if it's up to that. Let's see. You would like to tell people to move from their armchairs to some other ones. If the ith armchair is occupied by someone and the jth armchair is not, you can tell the person sitting in the ith armchair to move to the jth armchair. So, sure, a person can change their chair. The time it takes is the difference between positions. So apparently they are in a row with equal distances between consecutive chairs. You may perform this operation any number of times, but nothing is done in parallel. Every seat that was initially occupied must be free. Minimum time to do it. Don't we just sort? Oh, it's not exactly an over 2. All right. I thought for a moment that this is what's happening. There is, let's say there are 6 spots, and people in chairs are here. Let's say person 1, person 2, person 3 out of 6 positions. Then it's easy to say where everybody should go, because we just go in sorted order. Lowercase abc are empty chairs, and I claim just A will go to A, B to B, C to C. That's optimal. This is not the case here if the number of occupied armchairs is smaller than n over 2. N is up to 5,000, so we can use dp. There are some people here. Maybe, of course, the situation is more complicated. And now let's copy the same thing. Those are blocked spots. We need to assign some of those available spots to A, B, C, D, E, F to minimize the total length. I don't believe that some person will move more than once. So for everybody, it's just about assigning the final spot, and they will move directly there. Obviously, if we draw edges here, there will be no intersections. So it's like this. Like maybe A will go here, B there, C here, D here, and I'm out of spots. But for sure it will not happen that then E will get there. No, it would be better to do it like that. And maybe F will get here. That's something. This is not optimal because B gets here instead of there. But still, something like that. Is there any flow solution to this one? Yes. Matching of minimum cost matching can be done with a flow or Hungarian algorithm, but it's slower than quadratic. But here, because of no intersections, then always after, what do I want to say? Let's say that you decided about ABC already, then I claim that, as always with DP, the only important thing about it, the only thing you need to remember, is that the last used person was C, and the last used spot was this one. It doesn't matter how A and B were connected to the left. It matters what's the sum of values used, sum of distances. But what's important so far is the person last used, the last used available spot, and the sum of distances. The sum of distances can be big, but we will just make it value of dp. Like that. That's quadratic number of states of dp, so it's promising. Then for the next person we need to decide where he should be, which done naively it will be n cubic. That's too slow. LCS DP, I think so, yeah. We find some kind of matching between two strings, right? How to practice to become kind of the master? Very good question. Read this. In short, solve problems. It doesn't matter that you want to get candidate master. On every level it's the same thing. Maybe the very beginning and the very top it's different. And we use this only because there can be no intersections in the optimal solution. Thanks to this, we always move to the right with both person and the available slot. Slot, spot, both words make sense. Oh, I know. It's not that we need to iterate over where the next person will sit. I thought so, that then we care if where D will sit exactly, and we will iterate over all available slots on the right from the last used one. But no, we can just say that next available person is D, next available slot is here, and either we connect them or we move to one of them. So transitions are like this. From dpij we can move to dp of I j plus 1 by we skip this available slot, or we move like that. Here we say that person I takes spot j. We add distance, and that's it. Those are the only two possibilities. We cannot skip a person. A person must sit somewhere. Now those are constant time transitions, and that's it. Can we reduce the time complexity? I don't know. We can for sure reduce space complexity. For time, an interval of people will take interval of spots. For every such interval, we can, I'm sure, easily find where they should be, but it's not easy to say that there will be such an interval of people. Maybe we can do it faster with parametric search or alien streak. Maybe, I don't know. If that's indeed possible, then it would solve this problem in n times log of, I don't know, n squared. Something precise. I'm not sure. Let's say this. Billion doesn't really make sense. Let's assume it's log of n because I don't have any better idea. Maxim says there's linear solution. Maybe I should say which spots will not be used. Problems topic-wise versus random problems. You should use both. Read this. Linear solution. Maybe we should greedily decide about the first person, but then second person has a possibility to push the first one to the left. So maybe for every prefix of people we will know the optimal solution for that prefix. So if you know how to best assign A, B, C, D, but then you look at E and you think, oh, maybe it should push those previous people more to the left, at least like C and D will be pushed to the left. It would be something like this then, but that's only an idea. I don't know if it works. So maybe we processed already A, B, C, D, and they take intervals of those empty chairs, maybe interval from 4 to 4, and also interval from 8 to 10, or from 8 to 15, but that includes also some taken chairs. And now comes E. E is at some position, maybe it's 16, maybe it's 17, but around it there are a lot of taken chairs. If we either E should be connected with something to the right and then nothing happens, or it should be connected to this thing. Maybe 16 is taken, but we can connect this with 15, but it should push this thing more to the left. I have no idea how to do it. More about Alien's trick? Not now. It's a very complicated thing, so if you're watching this stream and you're learning something, you shouldn't know this trick. It's too difficult. DP on a stack. Then it will be greedy on a stack. I don't see how to do DP on a stack. We can maybe solve this problem greedily, and this is, I guess, a stack. This kind of interval. And now I'm thinking if indeed that's possible. I rarely use a word stack in my head when thinking about the solution, because this is just a tool. So I don't need to think that this is an array or a stack or something else. I need to think what should be done, and I'm aware of what can be done. Can we maintain some elements sorted? Yes, we can. We use a set for that. You don't need to say it. If you think like, okay, I can keep them sorted, and then what? Like maybe same thing here. This is a stack, so what? That's still my only hope. And we have a decision. I should check if it's better to connect it with the next available empty chair, or maybe take spot 15 and then what, everything moves by 1 to the left and that's it. Like just 8 will change to the previous available thing, maybe it will be merged with that. Well, this seems not hopeless, at least. It might work. I don't know if it's correct. Got your new pen tab. I actually got a whole new tablet, but it's pretty big and I don't like it. I will show you something. This is the old one. This is the new one. Okay, so you see the difference. Maybe this will show you the difference. Oh, and it thinks that I'm clicking stuff. So yeah, the new one is twice bigger, but it's hard to fit on my desk. So how much it costs? Small one is around $100, big one more than $200. One more thing we can try. I can, by the way, now maybe hide this. Yeah. Maybe we should think about the sum of distances in a bit different way. If you have a sequence and you have some set of starts, places from which you start, and some sequence of ends, and some positions, like this maybe. There are too many is. Now it's good. And then instead of saying that we match those, and so on, so this is too simple, like that. Instead of saying which goes where, we can do something else. In particular here, it doesn't matter how you connect those S's with E's. You will get the same sum of distances. And the drawing is wrong again. Yes, like that. First thing, there can be some borders where up to here there is the same number of starts and ends. And then the parts are independent. That's one possibility. And the other thing is, at every spot between two positions, like here, we can say what's the difference between the number of starts and ends here. The difference is 1. So there is one start here that will end to the right. So this passage, this corridor, will be traversed once. And the answer is the sum over those values. Or here we would compute that 3 people will traverse this corridor, this place between two consecutive positions. But I don't know how to use it. It will be, again, quadratic dp. I think still that's my idea for a linear solution. Now what do we do? I can implement the very first thing I got, the quadratic dp. This. In particular, I can try to make it linear space. Doesn't matter too much. It's 5,000 square. It will be 100 megabytes. So I easily fit in 500 megabytes allowed. Or I can try this greedy thing. And maybe, just maybe, I will get a linear solution, but I'm unsure about correctness. So I can as well spend here half an hour and then see that it's wasted. But maybe. Would it be easy to shift this interval by 1 to the left? A lot of connections will change. It's not that I can say that this e equal to 17 is then connected with here 6. Yeah, that's not easy. Even if doable, it's not easy. I wonder what Maxim described in comments. Let's quickly do dp, quadratic dp. Armchairs. Go about it. Let's use the one where I keep the difference between balance used. That seems interesting. But the balance can be negative. I wonder about how easiest to implement it and explain it to you. I'm talking about something different than this. Oh, let's do this. It will be easiest. This will be minimum cost to get something. new cost. When dealing with DP, I prefer to use infinity different than int max, because int max is very easy to overflow. Always, if I need to read a string. One means a person in some char. If there is no person, then I'm allowed to for free skip this person, because this person doesn't go anywhere. This person doesn't exist. So for free, I skip. Continue. Well, let's say this. Otherwise, I need to send this person somewhere. And either I skip this spot, or assuming that it's available, me is a helper variable, so that's my state, and that's me plus the distance. Like that. Whenever I get to the end with person, then that's good. This means now I'm looking at person n, so I'm already done with everything before that, and I can look at any spot. I'm lazy, I don't want to test on other samples. Maybe I should. I should. Impossible. ASMR. You're welcome. DP of 0, 0, it should go to like that. It can skip a few spots. That's maybe better looking. If that's no person, like that. All right, I see. So we are out of people, but we got to state DP of 36 for this input of 0, 1, 1, 1, 0, 0, 0. After this person is with this spot, so person is 2, spot is 5. That's the last connection we use. And after that, we are at person is 3, spot is 6. Because spot is smaller than n, we don't really consider that to be allowed, and we don't move from that forward. So here I should say that I should end just after the last alive person. Last alive is 0. like that. Maybe I can handle that easier, I don't know. And this is a case where last alive doesn't exist. Let's see what will happen. Oh, no, that's in free. 0. Well, if we never add something, then it should be 0. Last alive will be 0. So this will take 1. For n equal to 1, that would give me random error. Not this. 1, 0. No runtime error. Oh, okay, for n equal to 0 it will give me runtime error. Then never mind. dp of I0 becomes 0 for all I. Why? Finite tree, we're not allowed to skip people. So no, that's not what, that's wrong. That would be wrong to do. Hi JW. Good time to join the stream because I'm done with one problem and we'll move to something else. And yeah, flows is one of categories. I don't know. Big constraints for a flow. Java, stop spamming, but feel free to say meaningful stuff. I think it's the same DP. Sadly, not everyone can read Chinese. Array can be divided into segments. All cells in a segment are not people and are not new places for them, useless cells. Sure. And sure, I said that there can be those intervals. Interesting segment is shortest segment with balance 0, like minimal such segment. Oh, right, cool. Thank you, Kent Ido-san. I have bad memory for nicknames, so if I already know you, like I rated you, sorry for not remembering. Thank you for the rate. Sending good vibes. It worked, thank you. That's a nice thing about Twitch. It's so easy to, give somebody a smile by raiding. What I'm doing here is I solved the problem, and not this problem. What problem did I solve? Okay, we don't have a problem. I lost it. Well, I solved the problem, but there is a solution in better time complexity. I'm looking at its description, and I understand some of it because I had a related idea while thinking about the solution myself. this idea is a bit stronger than mine. There is a sequence of chairs, and if you sit, say, here and there, we use the fact that there will be no gap. Like here, this is a bad interval, because if you want to move a person from this S to this first E, and from second S to second E, that's clearly not optimal, because you should move them here. So this should be there. And there is this claim that we will use sequence of intervals where nothing is not used. Everything is either taken, there is a person there, or it's an empty thing where a person will go. In other words, if a person will move from this S to this E, if it will travel like this, it implies that everything in between is also used. Either there is a person sitting there right now, or there will be another person sitting there. So there will be no gaps. We will use such intervals where for sure then everything is used, so the count of ones must be equal to count of zeros. It's like bracket sequences where the number of opening and closing brackets is the same. I'll just here it's not doesn't matter, the prefix value is bigger than 0, that doesn't matter, so it's a bit simpler. And the number of such intervals is indeed linear. Next bugaboo. Okay. At least such comment can be funny. Test. 3 nipples. Does your nickname have anything to do with algorithms and 3 is there? And yeah, there's this thing, why there's linear number of such minimal intervals. This is how we can explain it. If you start with balance of 0 and then you have +1 for S and -1 for empty chair E, then the graph will look like this. And always, when you have a new value, like this guy, you can, from this, go to the left and you will meet some first position on the same height, the previous point on the same height. Then if it's on the same height, then this interval has balance of 0. For every new point, you will just go to the left and stop at the first point. And that's it. This is why there's linear number of them. We can easily find those candidates. So the solution is to imagine this graph. So we will need something like a map or an array for every height, what's the last occurrence of this height. And then whenever we have new height, we check that last occurrence and we say that this is possible interval. This is how we get linear number of candidates, and then we can do linear DP. Cool. That's... I can't believe that this already appeared somewhere, this kind of matching. There is, I would say, nothing new about this drawing. I saw it plenty of times in ICPC. So maybe, just maybe, this was not used because organizers knew about this problem before. But it's cool that such linear solution exists. Well known in China? Well, everything was well known in China and is. Fenwick, no need to repeat your comment once every minute. Come on. Alright, so armchairs is done and understood, including this thing. Upvoted for sure. And we can move on. When you have so many people, what? You're talking about the problem or the stream? Maybe now in a country? What? What's the full sentence? It seems that you're speaking half sentences. I will now choose something from the chat. Yeah, I'm taking problem suggestions. Now you can provide a link and say a few words. If you provided a link already, then don't bother repeating. I can scroll up. Fenwick, I'm not checking your suggestion because you suggested it like 5 times. So yeah, next boogaboo. Tree problem. What's this? Difficulty 2000. It's what's the current number of educational round? 100. Okay, so this is quite old. There is a tree, and we do something with GCD. Okay, that's some candidate. What else is there? Oh, when you have so many people, that's why it's well known in China. Okay, sorry. When you're streaming, it's sometimes hard to figure out what's going on. You need to think about multiple things at the same time, and you don't remember what happened 1 minute ago. Any more suggestions to consider? This? I solved that problem very recently. 24th of May. Did I just participate in that Codeforces round? Nope, not like that. It's annoying. I need to hit here and then standings. I solved ABCD, so I guess I participated. Yeah. Right, then this doesn't... in my YouTube channel you will find the solution of that problem B. Graph. 2400 is too hard, so nope. I streamed this round. You mean I streamed live? No. Discuss solutions with the author after the contest. I don't have good memory. Okay, this is the best candidate we have. So let's do this guy. Link. Oh, stream the solutions. Oh, sorry. Yeah, sure. Unusual runtime? What? In that problem B or what? What's going on? Shared problem next. Fenwick, stop. You're like people who write me some message, but also they say, please answer. I had no idea before that you want an answer. I tend to skip those emails and messages. Maybe it makes sense after a few days, you know, like if you send an email to somebody, they don't reply, then after multiple days, it makes sense to bump, to say that maybe the other person missed that email or something. But in the same message or after 1 minute, no. You're given a tree with n vertices. Number is in each vertex. G is greatest common divisor of the numbers written on some path. Dist is the number of vertices. Maximum value of distance such that GCD is greater than 1. Will we maybe iterate over GCD? Or run DFS from every vertex greedily? Maybe not. Sir, please answer. That doesn't make a big difference. Why no samples, sample explanations and no drawings? How do I hide this already? What did I do? Right. There is a tree. And if we focus on every prime, let's say p equal to 2, then there will be some vertices divisible by this prime. And I wonder what's the longest path with this prime. If we can quickly find those vertices, then I can run some kind of DFS for that, or DP. DP sounds fine. Bottom up, for every vertex I will update its parent. Yeah, that might work. 4.5 seconds time limit. Actually, indeed, big time limit sometimes is bad. Like in hard problems, it often means it's FFT, or the intended solution is actually very close in runtime to some brute force. Anyway, while reading the input, every number I can factorize, and then for every prime, I will know what vertices are divisible by this prime. Like also for p equal to 3, I will then know that, oh, maybe it's this vertex, and this vertex. So, like that. Every prime is separate and it's independent. The total, if for every prime I go through all vertices divisible by that prime, the total complexity will not exceed n log n, or actually n log of value. N log v, let's say, where v is limit for values. Values are ai, so log of a. Because every number, it is divisible only by log of a primes. That's total complexity we're aiming at. And now we're looking at particular set of vertices. And slow solution would be to run DFS, like to find longest path by running DFSs on connected components. But we have neighbors and we don't really want to waste time on there. Like maybe some vertex has a lot of neighbors and our complexity shouldn't be linear time per every prime. It should be just dependent on the number of marked vertices. The problem basically becomes this. Given a query, given a set with k vertices, find its diameter, meaning longest path, in O of k. That's the problem, not O of n. And then we will get total n log a. In O of n, it would be easy from some vertex that is maybe a leaf. From just some vertex, we run DFS to find the furthest, or we run BFS. But if we go through all the neighbors for every vertex, we also have in complexity those, well, all the vertices. n is the number of vertices in the whole tree. The tree has n vertices, and here this is a query, so we answer queries. There will be q queries. If we can do this, that the full problem will be solved. Every prime, basically, every prime value, like 2, 3, 5, 7, it gives us one such query. Then let's focus on the query. I think we can sort vertices bottom up, and then for every vertex just update its parent. Then it will be constant per vertex. I will know what's the longest path ending here, and I will update the proper value in my parent. And for every such parent, well, it will care about longest path down out of marked vertices and 2 longest paths to say that, well, there's here a path of length 3. It's quite standard tree exercise. 3DP, I guess. This problem is GCD counting. I already have a GCD problem. A long one. But let's start from scratch. Just reading the inputs, and then the interesting stuff will happen. And read the edges. To get numbering from 0 to n minus 1, I will subtract 1 after reading. Done. Do I want to factorize in square root? This times square root of that will be fine for that time limit. So I don't need a prime sieve, right? Oh, but I only want prime divisors. So prime sieve will be better. Even before reading the input, I will run prime sieve. Max is actually the maximum value of AI. For every j. Do this. Actually, let's just have that. For every value I want its prime divisors. For example, for 100 I want 2 and 5. Those are prime divisors. Then it's same stuff. If there are no prime divisors of a number, then it's prime. And for those, add the prime divisor, including yourself actually. So 5 will also have prime divisor 5. Edges. Why not factorize it with smallest prime factors? Memorizing. Oh, I can do this. I did something simple that works. It's fast enough. I know what you're talking about, and whatever. Oh, small bug. Thank you. Iterate over multiples of I, obviously, not over all the values. We can, by the way, quickly. Good night. Good night to you. We can quickly check if this is fine, like, by printing for every value. But usually I would do it only if the full code doesn't work. For I, we can iterate over prime divisors and print it. Oh, this is certainly wrong. If prime divisor is empty, not empty, then it means that it's a prime. For 6 it's 2, 3, for 10 it's 2, 5, for 16 it's just 2. Yeah, looks good to me. I should remove exclamation mark. Yep, you're right. I noticed that too. That's unnecessary. So unnecessary I will just remove. Hide it. And now there are those here. For every prime in divisors, I don't know, group for this prime, push back this vertex. First, we know for what vertices, like for prime 2, we know what vertices are marked, like on the drawing here, maybe those. After reading the tree, I think once I want to run the FS to gather the parents. This DFS handles, computes a parent for every vertex. I think I also need depth because I will need to sort by depth. Vietnamese and big fan of me. Welcome to the stream. Easier for each vertex to store its adjacency list by prime. Oh, you're right. Like, for every vertex, if it contains 10, wait. Maybe here I can have worse complexity. If for every vertex I go through all the neighbors, it's fine, right? So instead of this, I will have, like, for every vertex, I will consider its neighbors logarithmically many times. Yeah, I did something unnecessary, or at least I thought something unnecessary is needed. I wanted complicated DP with parents. Well, instead I can just do standard diameter algorithm where we run DFS from a vertex, we find the, well, BFS, whatever, we find the furthest, and from that we run this again. This is enough. Yeah, let's do that. Now, for every prime, for all the vertices here, maybe let's mark them. Let's call them V. Say marked V is true. Later we will unmark. And this should be a function. Answer maximize with this. get longest path, it gets marked vertices, a vector of marked vertices. Like that. Div2 is fine, so this blah 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 maxim set. Yeah, I'm aware now. Like, I didn't really need this. It was okay to have all of some of the grease. It's fine that maybe this vertex it has n neighbors, but still this vertex will be marked only logarithmically many times. All right. Dot visited of v. Let's find diameter with DFS. This is not your parent, and it's marked. Well, we can pass it. Distance +1. Div2 gets a vertex, it gets a previous vertex and the distance from the start. It will behave like this, and also furthest let's say this. I should, well, let's be nice, let's pass it by reference. During a contest I would just make it global. This code finds the furthest vertex. DFS of v -1 0 this. Do you use the 4 seconds limit thing? My solution is n log n, but DFSs are quite slow. Actually, if time limit was tight, maybe I should do BFS instead of DFS. Here, whatever. It's not quadratic, so I don't need to think exactly what will be the running time. It smells coding interviews on Skype. Shitty companies like, what? What? You mean this problem or just my stream? Or algorithms in general? So we do this, and we need to mark those things as visited too. And then DFS from furthest second. That's a standard algorithm to find diameter in a tree. You run DFS from anything, or BFS, find furthest vertex, and from that you find furthest. Like that, and the longest path, let's call it longest path. Furthest dot first stores that. Done. Is marked and visited. Answer. What else do you want? Group. Shadowed. Well, this is what happens when you code line by line. You don't bother to scroll up and fill everything properly. 0 instead of 1. But maybe I measure the distance in the number of edges, so maybe just I should add 1 at the end to the answer. It's slow, by the way, because of primesive and because of how I compiled. Now it will be faster. Here we go. It keeps giving us 0. That's bad. Yeah, that's very bad. Let's understand a little bit more. When we run a new DFS of type 1 or type 2. That's a lot of DFSs. Why the first value is huge? What is that? In is free and then array AI. What's happening? Maybe I didn't put a new line somewhere? I don't understand what's this. Not prime divisors, group. And group. Okay, well, if we add 1, what do I want to do? Yeah, I want to say that we start from distance 1 if we measure the number of vertices. What about now? 1, 2, 0. Great. This works, and should I check some kind of max test? It's linear times log. So it should be fast enough. Running for prime divisors of every number is a bit stupid because it doesn't actually take into account how the tree looks like. It always assumes that it's like 200,000 vertices with very particular groups. Running on test 6 for quite a lot of time. Camille asked me to be nicer on the stream, so everyone should have a good day. Thank you, Kostka. Usually when it's running so long, it means that you got time limit exceeded or something else, and Codeforces reruns your solution for multiple reasons. One thing is that actually if you slightly exceed the time limit, second time, if you get accepted, I mean, you get within time limits, you're good. And this is how Codeforces fights fluctuations. That's one thing. The other is you run it second time with different flags, so maybe third time, to display to you some more information. Like, oh, you got this runtime error because of out of bounds error. Oh, I use CERR? I should not. Yeah, of course. This is very slow. I don't even need to wait. There's no way that I can print millions of lines with flashing. Thank you, Eric, thank you. Yeah, 700 milliseconds. CERR, this thing. Those two lines have the same speed, I think. Print something, this, and then cout. Here's the thing. Both those lines are slow because of more than very slow because of this, because of flashing the output with ENDL. The only difference between those two lines is that CRR flashes the output even if you don't do this. Even if you use the fast new line, or if you don't put a new line at all, still CRR is forced to flash every time just because of the nature of error output. More often you want to see it, so it always flashes. But even if we used here like cout without flashing, and even if we didn't have this, still printing millions of tokens takes a lot of time. Printing is slow. Printing with flash is very slow. We can test it a little bit. I want to know too. Maybe then it will then depend on what kind of disk you use. HDD, SSD. Using namespace std bad practice? Yes, it is bad practice, but it's very convenient for competitive programming. Okay, let's measure the time of this. 10 million, we will print 10 million lines and it will not be flashed because this is not ENDL. If I just run this, it will be very slow because it's actually printed to my screen, so that's much slower than running something as with files. What I really want is to do this, let's say to some output file, and we can measure the time of that. This took 700 milliseconds. Around that, maybe 800. If I change this to ENDL, so you see, it's slower. 8 seconds. Just flashing is very slow. Let's say 10 times slower. If we don't do this, I expect that it will not be significantly different than the first runs. Yeah, 700 milliseconds. If we have fewer tokens, like just one character, it should be faster because, well, it's a few times less to print. If we just print the number, or maybe this number modulo 2, it should be fast. Yeah, sure. Maybe printing all the time the same character is faster. Those are not meaningful differences. You never should print more than millions of tokens. The required output is never that big. Is flashing just putting it on the screen? I think it's clearing the buffer, so in case of files it still moves it to the file, but flashing is, I think, clearing the buffer. Otherwise it's kept in buffer for speed. So it is not about putting it on the screen. Because it wouldn't make a difference then for files. So here's the lesson. If we do here something, this thing repeated 10 million times, it takes 1 second. If I add flashing, for example like this, or just by replacing this with CRR, I think this should also be 10 times slower. So instead of 1 second, it should take 10 seconds. Yeah. By the way, this redirects error output instead of standard output. 7 seconds, same thing. with CRR. This is 10 times slower than with cout, just because CRR, it flashes always. But this should have the same speed with cout and CRR, because anyway we flash. Can I do this? How do I... like that? I don't remember how to redirect both easily with like one command. This should have the same speed. In some programming languages, people put everything in the string and then output at the end. Yes, that should be faster. Printing has some overhead. C++ handles that with a buffer. Well, that was slower. Oh, maybe CRR is very stupid and ENDL flashes the output and then CRR flashes the output too. So maybe it's then twice slower. Hard to say. I don't know. Doesn't matter. Don't print millions of times. Some languages for sure have the buffer concept. Right. Well, I hope you learned something today. That's enough for me. Hop. I wonder how often during streams you can see somebody powering off their machine. But that's virtual machine. So yeah, thanks all for watching. Most likely in today's, maybe not most likely, maybe in today's Thursday I will absolve CodeGem. Yeah, plan for next week's is to generally solve this difficult Codeforces problems, or easier, and some interview problems like from LeetCode. Hot tub stream, I don't know, not in the summer. Summer is hot anyway, so why would you sit in a hot tub? 8-hour stream, that will come sooner than a hot tub stream. Thank you all for watching. Quick look if somebody is streaming. No. Again, if you want to be raided, you can stream just after me on Codeforces. I will raid you, of course, assuming you do some programming. LeetCode versus interview bit, they are not similar. Interview bit is educational. LeetCode has a bunch of problems. CSES, sometimes I focus on some category like geometry. All right, see you all, bye.